It's 5:30 here.
Oh, yeah. Now it switched. Yep.
You're
All
correct.
right. Okay, welcome everybody. This is IETF 111 Anima working group. If this is not what you sign up to, please try to find a different room. Otherwise, enjoy the ride. So if you have any problems, please, chime in on, on the audio channel or anything, because I'm sharing the slides. I can't see the chat right now, just looking at the queue. Let's get started with the usual stuff. IETF note well. I'm not going to read everything, just be aware everything you're saying here, doing public and so on. All the other stuff you should know. Logistics. Chair is here giving this slide deck, Sheng and myself. There are no blue sheets, but it's automatically done in the minutes. There is no Jabber scribe being asked for. That's the chat. Jana has thankfully stepped forward to be the minute taker, and then of course the slides and streams. You know that. So the one thing that we started last IETF is the early IPR disclosure process. So IPR disclosure early means when we adopt a working group draft, we're also already asking for IPR. When you followed the mailing list, you've seen that we exercised this last week for a draft that we quickly adopted because it was just a split out, and otherwise it happens during last call. Yep, so major achievement. We finished after, felt 100 years. In reality, I think it's 5-6 years. Our charter round 1 after last IETF in May, the cluster was resolved. So we now have 8 RFCs representing ANI and its validation use cases. And you should know all these documents, obviously. If you don't, if you joined Anima late and are just trying to figure out what the heck we're doing, then I'd recommend you to listen to the presentation I gave an hour ago at SACM working group, and there's another one at Ops Area on Friday, so first and last sessions of the week, providing the background of what we did so far. Yeah, so congratulations to everybody involved. Many things, from the authors to the contributors and supporters. If we did mention your name, our bad. And then of course also all the IETF process, which was really great. IETF review, ISG review, painful but very good. RFC editor and the tools team that allowed us to actually write these documents. So. All right, if we were here in person, I would, try to open a champagne bottle, so you'll just see the visual representation of that, how it opens autonomously. All right, back to work. So where are we at? So we have, I think, 7 or 8 active working group documents, which we are, now my screen is so small that I can't even see what I wrote here. The ASA guidelines, there is not going to be an update. We think that the document is ready for last call. We discussed that with the authors before the IETF. Brian is here online, so if there are any questions or so, please jump up and ask them here, but we'll just schedule a last call after the IETF. This document has gone through many. Yep, you want to talk? Please go ahead. Nope, you're not talking? I can't hear you.
Say hello, here I am.
Yeah. Great, and with video, excellent. Yep. And the audio is working. So yeah, so the document went, because we couldn't adopt it before Charter Round 2, it went through a lot of, working group feedback and revisions while it was still individual contributions. So that's why it's pretty much, it's finished now. Then we have async enroll, and where we split out the JWS voucher. So all this stuff is happening on Thursday when it's related to Brewski. Also the constraint voucher, that is something we could discuss.
To complete his talk.
Oh, wait, I clicked the wrong button. Stefan, can you go back to the line? Sorry. Yeah, so please go ahead.
Okay, just to have a little correction there.
The IETF Anima JWS voucher wasn't a split out of async and role. It was a separate or an individual submission, and it just became working group item. So we were talking about a split that we will talk on Thursday, I think.
Okay, then I'm confused. Let me fix this up after the meeting. Okay.
Okay.
Just
thanks.
to take that. Okay. WS. Let me take the notes. Okay. Right. So constraint joint proxy. That is also going to is ready for last call. We think the GRASS distribution is being presented. Voucher delegation. The authors told us chairs that they didn't find time to do work on it because of the other work that has higher priority. So that wasn't updated. So that's the working group documents. Then the non-working group documents, there are several new or revived works that have all slots here, so I'm not going to talk about them. There are also one that was updated. I haven't received slides from Bernardo, so that 6th slot today will probably skipping, so more time for the rest. And then the L2 friendly ACP, there was no ask, so probably also below the line of work priorities right now. Oh, Carlos, you're there? Please go ahead. Yeah.
Yeah. Can you hear me now? Yes.
Yep.
I uploaded the slides to the materials as
Okay.
I requested that, so I can send you the slides if you want. But
Oh no, that's fine. That's fine. I just didn't check. I think the uploaded thingy in the last hour, so just looked at email. So let me find the slides and accept them while the presentation is on. Thank you.
Okay, thanks.
All right. So yeah, that's basically the work. There's obviously a lot of stuff below the line that has expired. Just general reminders, we have a weekly, almost most of the time, weekly Brewski design team on Thursday morning with the information here and the people that most regularly show up. That's also what did the hackathon. That's also going to be reported on Thursday. We also have our GitHub that you're more than welcome to put any Anima related work into. Just send email to get invited to it if you haven't been using it. Yeah, so let's go to the agenda. This is just copied over from the CodeMD, so please feel free to also add to your notes there. And let's get started with Shunxiao on the GRASS distribution. If you can step to the mic and
yes,
do you want to show the slides yourself, or do you want me to show the slides?
I think you can share my screen. I think it's easier.
Yep, please go ahead.
With the slides ready.
Yep. You need to
finish.
request sharing screen. Yep. And then grant screen.
Can you see my screen now?
No, maybe because I'm still sharing. I'm not sure how I let's say expand video full screen. I think I need to stop sharing the slides here or something.
Yeah, maybe.
Oh no, logistical
I
problems.
guess completely, or in the worst case, you can also share your screen. Then we just move the slides.
There we go. And now try again.
I already. Okay, I canceled now. Now I ask to
Try
share
again.
screen.
Yep. Ask to send screen. It's green.
Yeah.
Did you get it?
I'm not sure.
A screen share is being started.
Yes, exactly. Yep. Yeah.
Oh,
But
wow.
do you really want to? Yes. Okay.
Sharing is started. Not yet.
Okay. Yeah. So we're really on time. Yeah. So yeah. This is although it's probably late right now in Munich. So now I'm only the one here from Munich to provide updates. So this is the update for the third version of our working group draft for the graphs distribution. I'm Xunxiao. Okay, this is just a recall to sketch the main scope of our draft. We focus on the information distribution module in the ANI, and we also involve with the grasp extension, try to reuse all the grasp APIs that have been proposed, so that we can really reuse the functionalities below there, and to try to maximize the utilization, and also try to get more enriched information distribution functionalities above there to support the upper layer application. Okay, I will skip this. This is actually the page that shows that this working group document was adopted last year, and this is the main change from 0 to 1. We actually merged the bug -05 from Brian, and also try to talk about how to do the information distribution for the bug information. And after that, we try to focus on address the comments about use case. This is the last version. And this is the new updates from the last version. Right now, we actually changed the first version, because I'm right now mainly responsible for the updating since many versions already. And so I'm taking the first version right now. And in this version, we still focus on polishing our use case and the requirement. So so specifically, what we change from the last version is that but this is still the old slice. I would directly move to the new one. The new change is that we still are focusing on addressing the comments about use case, because this is very important to motivate this work, so that people can easily understand why we are proposing the information distribution for the ANI. So what we exactly changed is that we changed the use case. Previously, it was named as distributed computing to in-network computing, because we think this scenario or use case is more suitable for Anima, because in Anima, in an ANI, basically all the ASS is providing a kind of computing functionality and services for the network service. And those ASS were supposed to run inside of the network. So that's why we think it's maybe more appropriate to call it to motivate it by in-network computing scenarios and use cases. So basically this can better generalize the requirement of the most application scenario. So out of that, we basically modified the section 2 in the use cases, and we further generalized the requirement for the in-network computing use cases. Basically, right now we developed 2 types of requirement. The first requirement is about data backup, and the second one is about data aggregation. So I will talk about it further. So for the first requirement, we think that maybe maybe we can also consider their ASS. We may have backup ASS, ASA or AFs in the network. So basically those backup or copy of the original ASS may want to basically backup or synchronize all the data when running the services provided to the user. So we think information distribution should consider how to support data backup as a new kind of a requirement for the information distribution. And basically it can involve master and slave synchronization. So the copy of the original ASA can keep the slave node up to date. So for example, this can have many applications in mobile wireless network, for example, or the 3GPP defined core network functions basically have as set of that network function instances. So basically, if we would like to promote Anima ANI to actually support those network functions, we can try to imagine that how this graphs protocols or specifications can further support these kind of data backup information distribution. So for the second use case we are right now considering is that maybe information distribution should consider how to support data aggregation. Data aggregation basically means that two ASA, here AFA and AFB may generate different set of data. And basically these two ASA, A and B here may cooperate with each other. So eventually they would like to merge or aggregate their individual data set so that they will get an aggregated one. So this also has many examples. So for example, right now the very popular artificial intelligence, if you deploy those distributed artificial agents, artificial intelligence agents in the network as in-network computing use cases, you basically train the data and also derive the neural networks parameters with distributed artificial intelligence training. So in this case, basically, how to aggregate those trained parameters that you derived locally across the network. So we are considering how this can be, how this kind of work or jobs, tasks can be further supported in our ANI by the information distribution module. So right now, we think the in-network computing use cases are really matching the ANI and the ASS applications at the higher layer. And we think this is very important functionalities that we should really think about. Maybe this can better revise our current draft in order to address some of the comments that appears in our mailing list. So a further question here, I actually didn't have too much information for that right now. So if we are talking about data backup or data aggregation, maybe we should further think about whether information distribution should consider consensus among those AFs or ASA. Okay, so this is the main updates from for this draft, and of course we will further update the current text, and we will focus on the other set of comments to prepare the next version, because maybe we are thinking about maybe after 2 more updates or 1 major update, maybe we can consider to submit to the external review. Yeah, okay, thanks. Any questions or comments or suggestions?
Yeah, thank you very much.
Yeah.
So I was wondering,
so should I start sharing my screen and give the screen to you?
Sure, that's fine.
Okay. Yeah.
Are there any other specific, working groups or so you could think of that would have feedback? Then just reach out to them or let us chairs know, and we can help just to expand the scope of reviews, bring it up on the mailing list again. So yeah, definitely let's plan to have this in, last call before next IETF, I think. And from my side, I think it should be getting close to that. So I'll also check it out again.
Yeah.
Okay, let me take the next slot.
So,
any more questions?
Yes, please.
Yeah, you said you need another 2 or
maybe
one more
one
major update. So is there many outstanding comments, or what's the reason? I thought it's already stable enough.
Yes. Because I think at the solution part, also we got comment from Brian, and that we should maybe polish it in the solution part further, because we think we think that part is not, let's say, quite mature or quite good yet. Yeah, that's actually the main reason. Yeah.
Okay, got it. Thank you.
No problem.
Okay, let's get to the next slot. So this is work that I had started in before we went into round one, around IETF 100, 101. So we let it expire to concentrate on our round one work, which obviously is now finished. So now I revived that work. Right now there is only minor textual improvement. The co-author started to also provide input on that. So I just wanted to give a reminder about this work, and hope that people are start getting interest and provide feedback and help to finish this fairly quickly, because it's not really that difficult. So this is really about what are we missing for, let's say, RFC 8368, which is using Anima for existing networks through the ACP. And the main issue is really to bring up the ability from the NOC to interconnect with the ANI network, and concentrate on the things that are for Bootstrap, but also useful throughout the life cycle. So what do we really need for that most fundamentally, right? So how does the NOC learn about newly enrolled devices? I wouldn't necessarily assume that the enrollment service is tightly integrated with whatever has to come next. So it certainly would be good if this can be independent of each other. And so one of the simple answers that we've used in pre-standard implementation is to simply rely on syslog. So if a device becomes available on the ACP, it syslogs itself. So question, where does it find the syslog server, right? So then the other thing is, how do we make the certificates actually work and get renewed correctly? We need time synchronization, already part of the ask and requirement in RFC 8994 ACP, but not specified how. So auto configuration of NTP, finding NTP server and using that would be the second key issue. And then finally, how do you get operators to access the device? So SSH for CLI, netconf via SSH or TLS for automated system, netconf zero touch, callback as well. All of these require something to auto-discover in the case of explicitly SSHing or netconf into a device. One of the problems is that the domain certificates themselves do not provide really authorization support and privileges. That is typically only possible when you have appropriate servers like Radius, Diameter, or TechX Plus. So auto discovery and auto configuration of these services with the appropriate authentication server, authorization server, is kind of the next important thing. And the way on how these documents are proposed to do it is that simply we're using DNS SD announcement of the messages of the services, and then every network node can auto configure them. And so that then gets the question, how do we do DNS compatible service discovery, because we don't need all the normal DNS. And so that is basically done with GRASP, which is which is the other draft that I have some slides at the end of this deck, right? And obviously this service discovery can be reused for a lot of additional services, firmware update, even OAM DNS, a lot of other services, IPFix, NetFlow, DHCP parameters, SNMP traps, and so on. So there are a lot of infrastructure services for which auto announcement, auto discovery might be useful, but not necessarily to be standardized in the first round. So as far as the DNS, how it works, right? So there is basically, an update I'm giving tomorrow for the DNS SD working group. I don't want to repeat all the stuff we know here in Anima, but I think the one important thing to remember is that the ANI is designed so that it does not require DNS, because we don't need DNS names for nodes, because the ACP addresses are pretty much the names, right? But we do need services discovery, and we don't have that, other than that GRASP is a very generic solution that we want to use for it. So And here is kind of a couple of explanation why really reusing existing unicast or multicast DNS is difficult and not really what we want. So ultimately, the planned architecture is that really what we want to do is to have something which is compatible with DNS-SD, add the service API layer to the applications that are announcing and trying to discover services through that API. And then Grasp DNS-SD is going to be an equivalent alternative to RFC 6763, which is the mapping of the service requests and announcements to DNS, which is fairly convoluted, using multiple, at least 4 different type of resource records, whereas in Grasp, it really is very simple, a single Grasp objective to announce, discover services, and then use Grasp across the ACP. So I showed this, this is basically the CDDL for the DNS SD compatible Grasp objective proposal, and that has all the, well-known parameters that you know from DNS SD: the name of the service, the instance name, and then the priority, the weight, an additional extension key value pairs, which is defined in DNS-SD, and then also, extensions we can only do in Grasp because we're flooding it hop by hop, and that I think is one of the important things to do a decentralized solution, which is the distance of the announcer of the service to the consumer of the service. We can track that as well through the Grasp TTL, so that's something we couldn't do through unicast DNS, for example. So this is kind of the obviously the core of the specification of that draft, and I don't want to go into too many more details here. The other part, of course, that comes out of it is that we, for most of the things we would do across Grasp, if they really are meant to be services in the same way as DNS-SD, we don't need separate registry for it. We have our Grasp objective registry, and whenever we're doing something which is not a DNS type service, we can basically still use that, but the idea would be to have for all these services that really are have multiple discovery mechanisms, whether it's DNS-SD with Grasp or legacy mechanisms or others, just use the existing services registry and then reuse this for Grasp. And I've already used the proposed format for this here for the EST service that the ACP uses. So would be in Grasp calling these srv.est for the objective name, and that means that the name like EST would have to be registered in the IANA services registry. So finally, then, this is all cool stuff for networks, and maybe not all of the networks will want to have a full ACP, and the ACP is just the transport and security infrastructure for Grasp. So maybe there is some other follow-up work that would be useful to figure out a more lightweight transport for Grasp, so that especially the service discovery with Grasp would be a good reason for networks to deploy Grasp even when it cannot have the full ACP. And one of the ideas, of course, is that we just need to match the security of existing networks where it is the biggest attack vector. And in most of the networks today, this is the IGP, which is typically just protected by ACLs, forming a clamshell around the network. And so if we simply define a transport that says, well, we're just going to build TCP connections to any neighbor that is also an authorized IGP neighbor, then we can very simply deploy Grasp without any of the other ANI expectation that we have, and for example use this service discovery as a great way to further proliferate Grasp into non-ANI networks. Yep, so that's pretty much what I had. Any questions?
But I noticed mystery
So
operation.
you're very quiet.
Can you hear me now?
Yep.
Yeah, I noticed a very mysterious operation from you. It seems you submit both the old version with the old name and the new version at the same day. Is that the intent?
So the one document, which is what was called NOC autoconfig, I renamed when I uploaded it after a really good session with Ignas, where a lot of networks don't necessarily have something called a NOC, but would call it differently. So then I was going back in the name, but I'm not aware that I uploaded any old slides. So maybe we can take that offline, unless it's of interest to the whole working group now.
Okay, sounds good.
All right, then let's have the next person step up. I think that should be, we look at the CodeMD, that should be Yiju. Do you want to share the slides yourself?
Hey, Tulis, I had my hand up.
I noticed that Brian was in the queue.
Oh, Brian, oh, sorry. Wait a second. Oh, yeah, please go forward. Sorry.
Okay, just very briefly. The prototype code that I wrote, the hard part was interpreting the DNS-SD records, which are just, it's a retrofit on top of the DNS. It's really not very clean because you have to look at different record types and figure out how they relate to one another. And it's just a mess, to be honest. The rest of it's trivial.
Yeah, that's why the proposal doesn't really use any of the DNS record types, right? So I think the functionality that you have might be for translating DNS SD when somebody announces DNS SD, but when we actually do native, grasp announcers, then it's that simple record that I showed on the prior slide. And obviously the idea would be to have an API where you can, instead of using actual DNS records, directly just create the grasp record. Yeah, translating that.
Absolutely.
Yeah, I wasn't aware that you were trying to get into that mess. I remember that I did several years back, and yeah, that's really very complicated. But remember, that was the service originates from AppleTalk, and that was fairly simple. And then basically, you had to map it to DNS, and there was no easier way than to do it, right? So unfortunately, DNS wasn't really very well extensible. So that's a good discussion for tomorrow.
DNS is not a good.
Yeah,
DNS is not a good foundation for this. That was my conclusion.
But the service, what he did on the API side, that's really nice. So, all right.
Okay, you can take me out of the queue if you know what button to press.
I'll rather. Do you want to present the slide? Would you want to share a slide? Yep. Here, wait a second. Let me accept that. Yep. Okay.
Can you see my screen?
No, I don't think you're sharing yet. Yep. Now it's starting.
Okay.
We need to grant their hearing request. I just did.
You're again very quiet, Sheng.
Can you see my screen? Okay, good. Hello. This is Yijo. I'm going to present this autonomic IP to access control group mapping information via the grasp objective. So the first page is going to a little bit, excuse me, a little bit background of the group-based policy, because in the campus network, we're kind of moving from the traditional subnet-based ACL to the group-based policy. So traditionally, we're using the pre-known VLAN and the subnet plus the IP prefix-based ACL as the access control mechanism, and such mechanism is relatively static. So it is tying the same set of groups of hosts by assuming that they are accessing from a pre-assigned switch and all switch ports, and assigned VLAN and the tied subnet or IP prefix. But it's no longer the case, because most of the campus networks now allow their employees or guests to bring their own devices and try to access the laptop from either any location in the campus network. So it is no longer the case that the people accessing from maybe the same floor of a building are belonging to a same group, say the engineering group or accounting group. And also in the conventional provisioning, the IP prefixes are used as the source or destination rules in the ACL. And if we insist on using it when the people are allowed to move or bring their own devices, it would be a big burden on provision or maintenance when these prefixes of the end hosts is not known in advance. So the group-based policy is emerging and actually is being widely used as a replacement now. The admin defines the groups and the rules based on those groups in advance. And those groups and the policies or the rules are irrespective of the end user's IP or IP prefixes. At the same time, the group-based policy would require the policy execution point, PEP, to locally store the IP prefix to access control group ID information, the mapping information, because for the PEP point, you need to check against the data packet and try to map from the IP address to the group address, then check against the rule, then using this group-based rule to execute the policy. So that's the basic usage scenario of the group-based policy. Then here comes to two topologies, actually. This one is a simple one. This is a simple topology which we normally use in a campus network. If we look at the left-hand side, here we show the 3 layers of the switches. Of course, it can be 2 layers or more layers, maybe. So we defined 2 terms here. The first one is called PEP, Policy Enforcement Point. Depending on the different scales or of the network, also different deployment. For example, whether the uplink of a certain layer of the switches is a dual homed or single homed. Also depending on the layer 2 or layer 3 the topology, there are different places we can put the PEP from the highly centralized. That means we only put the PEP at the core layer, to the highly distributed. That means we put the PEP at every access switches. Another term we define is called AAP, Access Authentication Point. In this picture, each of the access switch is an AAP. It's responsible for its attaching end users. So at the same time, the places to put AAP also vary. The functionality of the AAP, there are 2 functionality. The first one is the AAP need to obtain the IP address or prefix information assigned to its attaching end host. There are different ways to do it, like the DHCP snooping or proxy, or a DHCP prefix delegation, or even via some of the relatively static configurations. The second functionality of the AAP is it can obtain the access group ID information. For example, via the IEEE 802.1x plus AAA. So when it tries to do the authentication at the same time, it obtains the group ID information tied to this user or end host. So the AAP, the access authentication point, can keep the IP and the group bindings. So here comes the requirement for the grasp defined in Anima working group. The PEPs, the policy enforcement points, would like to get the IP prefix to group mapping information from the AAP. There are two reasons why it is required. The first one is the PEP. The PEP points and the AAP are normally on the different nodes. So of course, if they are in some cases, if they are on the same nodes, then such information distribution would not be required. The second reason is the PEP, in order to execute the policy, it would require the full set of the information of both the source source group information and the destination group information, while most of the AAP only have a subset of such information because it's only responsible for a subset of the end hosts, which are the attaching end host to itself. So this is a simple topology show of a campus network. Then I will move to sorry. Yeah, this is a more complex topology. Here, the left-hand side, the picture shows a more complex topology for campus. We have a headquarter, we have a branches, and on the top we have the internet user access the campus via the tunnel, via the VPN tunnel. I mean, so. There's actually the implications are similar. The PAPs can be located on different places, and specific traffic can be directed to a certain PAP. For example, if we look at a headquarter, there is a firewall we call the PAP1. That PAP is designated only for the intra-headquarter traffic. So that means it's normally using together with some of the traffic direction. And of course, more complex group definition or policy enforcement rules would be defined. For example, a single user may belong to more than one group. But anyway, the implication, the requirements are the same. Points are still want to IP to group mapping information from the AAP. Given these two example topology, so here is the proposal we are having in the document. We want to define a new grasp objective to distribute the IP address or prefix to distribute the mapping information from the IP address or prefix to the access control group ID. So I roughly show the objective defined here. Basically, I think there are maybe 2 points to be required to be brought up. The first one is we allow the single IP address or prefix to map to more than one group ID. The second one is thanks to the contributors, we are using the IETF CBER network address draft definition for the IPv4 and the IPv6 address and the prefix. So that's a format we are going to use. The procedures. We have normally the providing node should be the AAP access authentication point. It sends an unsolicited synchronization message to the policy enforcement point, PAP, upon a new binding. The binding means the binding here means the IP to group ID tie. So either upon a new binding, or there is updating of the old binding, or there is a withdrawal. The second possibility is it will send a synchronization message as a response whenever it receives a request. The requesting node would be a PAP point. It will send a request for the mapping information when either the source or the destination group is not available from the data packet. The reason we show the reason why we say either source or destination group is because for some of the data packet encapsulation, the source group ID can be injected directly to the data plane. So it really depends on how the what the encapsulation is. So some of the time, both of the source and destination should be requested, but some of the time only one of them should be requested.
We're somewhat late. Can you try to speed up so that
okay.
the other
yeah.
Thank you.
So there's one more thing I think worth to be discussed, maybe in the mailing list or direct to me. So currently we are having the AAP talk to PAP, whether we should allow the PAP cascaded PAPs to send to request and response among themselves. So this is the thing that maybe you can feedback to the mailing list. I think that's all. The next steps, we're going to revise it and yeah, edit based on the comments we have received and going to receive in the mailing list. I think that's all. Any questions?
Yeah, thank you very much. I think high level, I didn't have the time to go into the details, but if this is primarily policy distribution, I'm wondering if this could ride on top of the GRASP information distribution thing, or whether it needs to be a complete standalone GRASP objective definition.
Oh, yeah, the thing is, this one actually doesn't propose to do the policy itself. It is just assuming the campus network has already trying to use the group-based policy. So this is only trying to distribute the mapping information from the IP prefix to the group. So the policy itself, the distribution of the policy rules itself doesn't, I mean, it's not in this document.
Right. Yeah, let's take it offline due
sure.
to time.
Yeah, just two quick comments. One is you may find out you can benefit from use the ACP directly to secure your communication. Secondly is what you described looks to me like some kind of autonomic service agent. If yes, you can describe in that way that will make us better to judge whether you fit in Anima or not. Thank you.
Oh yeah, thanks. Yeah. There, just a quick response. Actually, in the document we mentioned the ASA part, but in the slideshow we didn't. But yeah.
Okay, thank you.
Joanna, do you want to share your slides yourself, or should I share them? If you're saying something, we can't hear you. Now you can hear. Go ahead.
Can you hear me?
Yep.
We can't see your screen. Let's share your screen.
Thomas, I will share my screen.
Do you want to share your screen, or should I share your screen? Or your slides? What do you want?
Okay. I can't find auto the screen button, so you help me to share screen.
You have to click on screen sharing if you want to do it. But you know what? I can simply show the slides, and you say next slide. How about that? Does it work for you?
Yeah. Okay. This is Joanna speaking. I'm going to introduce an auto-deployment mechanism for resource-based network services. Next. This draft specifies an auto-deployment mechanism that deploys resource-based network services through the autonomic control plane in an autonomic network services. The GRASP is running in ACP to exchange the information among the autonomic node so that the resource among the service paths can be coordinated. What is services is a unicast or multicast flow which has a source and a destination. What is the network services? A new services flow contains one or more service flow. Resource-based network services has a reference requirement which has an extremely assured minimum bandwidth, assured maximum end-to-end deliver latency, and so on. Resource-based network services can satisfy the requirement of the network services, which has a definite ingress node and the egress node. The encapsulated time, encapsulated type is VXLAN or GRE or MPS or segment routing. Next. Okay, this is the detailed scenario. There are two autonomic functions One is resource-based network service auto-deployment. Another is a resource-based network path auto-deployment. So the service or path information with the resource need to be exchanged among the service initiate, network ingress, and SP node, P node, egress node. Next. Okay, according to RFC 8993, which is a reference model for autonomic networking, there are specific autonomic service agents, the grasp in autonomic control plane. The different ASAs exchange the information via grasp protocol. According to the RFC 8990, the new grasp objective option is needed to be designed, which is used to identify the objective for the purpose of discovery, negotiation, or synchronization. Next. Okay, this slide about the new grasp objective option. Thanks Michael Rison and Bryn for the suggestion and comments. As the RFC 8991, the new grasp objective option contains name, objective flag, and the objective value. So the new grasp objective option is running between the network service initiate and the ingress PE and SPE. The name is the service deployment value, which is needed to be assigned by Anima registration. The objective flag is about the is valid for discovery and negotiation and synchronization. The objective value is a data structure as follows. For example, the service identifier, which used to distinguish different network services, maybe one grasp message contain more than one service network services. Service deployment type, which indicates that is new or update or deleted. The service resource information, which ensure the results of network services. For example, the different resource type have different solution. For example, the bandwidth or latency type. The resource value, which indicates the detailed value. The service deployment status, which indicates deployed success or failure and the related reason for the failures. Okay, next.
Joanna, can you speed up? We need to finish this within 5 minutes to still have the last slot. If you can stay high level, I think most of us have problems to grasping all these tiny details within a presentation. So.
Okay, I got it.
Mm-hmm.
Okay, this new dropped objective option is running along the network service paths among the ingress PE and SP node, P node, and the ingress PE. This definition is the same as the previous definition. Okay, I will introduce how to use it. Next. Okay, this is a process of network service auto deployment. If a new or update network service deployment occur, the network service initiates in the SPE a grasp request negotiation message. The deployment type filled with the new or update type. The SPE first detects whether the UNI interface meets the resource, the service resource information, and then detect whether the network path meets the PAN's resource information. If they all satisfy the resource information, the SP will send back a grasp negotiation with the service deployment status field deployment success. If one of the preceding item does not meet the requirement, the SP will send back a grasp negotiation message with a service deployment state, field deployment failure, and the related reason. If withdraw network service deployment, the network service initiate to notify SP to release the related information. Okay, next. This is about the resource-based network path deployment. The different from the previous process, the SP send the grasp request negotiation along the down node along the path. So if the one network node found out the resource information can't satisfy the resource information, it will send back the grasp negotiation message to the upstairs node. Okay, the withdrawal path deployment is also have the same principle. The SP will send its own downstream node along the path. The network node will release the related resource before sending back a grasp negotiation message with the service path deployment status with the withdrawal success. Okay, next. Different results have the different process. For example, if the resource is the minimum bandwidth, the nodes, the outbound interface of the node and the inbound interface of the node along the path must satisfy this parameter. Therefore, the bandwidth parameter carried in a grasp request negotiation message along the path can be the same. If it is the maximum end-to-end delivered latency, because it's the sum of the forwarding delay and the link delay, therefore the latency resource requirement carried in a grasp request negotiation sender can be the different. Next. This maxim also considers the compatibility. For example, in the MPI scenario, the RSVP protocol, which is the distributed mode, is used for the bandwidth regulation. So the autonomic service agent described in this draft can also interact with the RSVP instead of the grasp. It will also consider the security consideration. It's according to the ACP described in RFC 8994.
Can we finish here? I mean, I think we're going into the technical things maybe, and we're sorry, we're at the end of the
okay.
I still wanted to give Bernard.
It's all.
Yeah, sorry about that.
Okay.
Even now that we have 2 hours, it's tight. Any questions about this? Please, sounds very interesting. Please check if you find time to read it and comment on the list. Carlos, can you step forward? And also, if you can stay high level, we're already at the end of the official time, so maybe just do a good spin of why people should be interested and read it instead of just explaining all the details again.
Sure. Can I share my screen?
Yeah, I think you should. It says...
but I have it requested. I don't see it. I just requested to share the screen.
Maybe I need to... Oh, okay. It was me. Sorry.
Yeah.
Okay.
Here we are.
Okay, perfect. So let me very quickly. So this is a presentation of a draft that we wrote some time ago about autonomic setup of fog monitoring agents. So the motivation for this presentation was basically we did already a first presentation 2 years ago, and we received some feedback from Michael. Even we had some offline meetings discussing potential things to do. But at that time, we couldn't really continue the work, also because the charter did not really allow to do or to cover the kind of work that this draft does. So we'd like to resume now this effort, basically under the charter item that is shown in the screen. So basically document a potential generic use of autonomic networking and GRASP. And the idea here today, that I will be very, very brief because we are over time, is to see whether there is interest in the working group to explore this further. And I had to say a disclaimer, even though we wrote this draft, we are not experts in GRASP and in Anima, so it was an exercise from our side to see whether the use case that we have in mind, GRASP, could basically fulfill all the requirements. So the idea is that, well, we have virtualization. I think all of us are probably very much aware of this. We have SFC, and we may have now virtualization going into mobile devices, getting into the actual, even into the end user devices. So we have this concept of fog that is extending the virtualization into the edge and into even the final user devices. So we may have SFCs composed of functions that are running on fixed infrastructure nodes and also on mobile nodes. For example, we have here in this simple scenario different nodes, and we have functions, function 1 and function 2, that originally was running function 1 in fog node A and function 2 in fog node B, but because of the mobility or whatever other reason, we need to move function 1 to function 2. So basically, to support this kind of very dynamic and volatile environments that differ from data center typical scenarios, we need to have a more agile monitoring platform. So this is our own solution about fog monitoring platform, but the idea is that this could even apply to other orchestration solutions where we need to have a monitoring platform capable of being bootstrapped autonomously. So in our particular solution, that is an example, we have fog agents running on the nodes with resources, and we have a centralized controller that is gathering the input, or we may have a set of controllers gathering the input, and based on that, triggering orchestration actions. So the idea here, well, that will be the architecture. I will not go into the details, but the idea is to use GRASP to do this autonomic setup of the fog agents running on the devices and the controller. And in the document, we have a potential solution, but again, it will be very much welcome if experts in the working group could take a look and provide feedback about whether this makes sense or whether there are some things to be improved or even wrong. And we define the use of GRASP with different mechanisms, new objectives and objective options, and different multicast scopes defined for doing the discovery. Well, basically, this is it. The idea will be whether this type of a scenario about setting up monitoring, this is for fog, but could be for any type of virtualization environment, could be of interest as a thing or use case to document the use of GRASP for this type of scenario. And if so, just to provide feedback so we can continue working on this now that we feel that it could fit the charter. And that's it, very briefly.
Yeah, thank you very much. Also for being short and crisp. Any questions?
Yeah, Carlos, I do have a little problem with the terminology you use for fog, because I didn't find it in any other IETF documents. So it's more commercial terminology than technology terminology for me. So from my understanding, what you are working on is more like ad hoc network, which is more technical words. So if that's right, I would like you change that for next time. Otherwise, I saw it interesting work.
Okay, thanks. I mean, the term is not exactly ad hoc, but it's true that it's a term that is heavily and probably used with different meanings depending on the context. But the idea is to basically extend the edge network to also include the
I know.
user devices.
And I actually know what fork means in the commercial words, but and what I say is we don't have such definition in IETF. You need a reference or you change the terminology, which IETF understand. Right.
Okay, I'll take a look at that. Thanks for the comment.
Yeah.
I also have one question. Is any of this, been looked at the research side as well? So something like CoinRG or DINRG, right? So it seems like, this type of distributed, more application-like stuff. I was wondering if there is any adjacency. Not to try to shy you away from Anima because they're not standardizing anything. So, that would certainly go here if and when needed. But I was just wondering if they have any thoughts about this.
We have presented some stuff on folk stuff in SFC. In Coin, not yet. Although we did some related work on discovery of resources. So we did something, but not specifically to this. What I can also say is that we are doing research on this, the use of Anima and related stuff in some European projects. So we had research, we have additional results that we could present in other working groups. This was just specifically about the autonomous bootstrapping and setup of the monitoring part. Okay.
Cool. Yeah, thank you very much.
Thanks.
Yeah, so I think that brings our Monday agenda to the close. If there's anything else, feel free to ping us during the week, and then see you back on Thursday.
Hold on a second. One last word from Chair. This session we receive a lot interesting new works, thanks to the authors. But I would like to remind the authors, please invoke the discussion in the mailing list. The more, attraction you get from in the mailing list, the more possibility, the chairs look it more seriously and has more possibility to adopt in the future. Thank you.